We are continuing on with Unit 8. This is the second part of Learning Target 8B, and in this video we're going to learn how to multiply two binomials together and then simplify. So we're going to use this through the FOIL method. Maybe you've also heard the phrase the double distributive property, but what we're going to look at is when I have two binomials. So I have two polynomials, each with two terms, and how would I multiply those all together? So in our last video, we looked at how do I take a monomial or a single term and distribute that into a polynomial. And in this video, we're going to focus on what happens when I have two binomials that I have to multiply and make sure I multiply each piece together. So what FOIL stands for is first, outer, inner, last. And what that represents is the two first terms. So the 3x and the 6x squared are the first terms in each of these binomials. So the first things I would multiply would be 3x times 6x squared, which we have down here in blue. The outer terms I would then multiply, which would be the 3x times the 9x. So that will be my second term. Notice I'm going to add all of these terms together because individually I'm multiplying two at a time, but then I should end up with 4 terms total. My inner terms are the two terms that are closest to each other. So that would be the -1 times the 6x squared. And then my last terms is the last term on each binomial, so the -1 times the 9x. From here, we would simplify each one of those by using our properties of exponents and then combine any like terms if we can. For this example, though, I wanted to show it completely unsimplified, just where we're multiplying the two, so we can see that we end up with 4 terms. Now, before we simplify in each one of these, when I have a binomial times a binomial, I will always end up with 4 terms before I do any simplification. And the reason being is each binomial has 2 terms, so I'm multiplying that 2 terms to 2 other terms, and we know that 2 times 2 is 4, which is why we end up with 4 separate terms before we start combining. Now, of course, if we can combine any like terms, then that might narrow that down, and our final answer might not have 4 terms in it. But in our first step, when we multiply, I should always have 4 terms, since this whole video will be about binomials times binomials. Let's look at example 1. It says 5x minus 3 times 2x plus 1. So using FOIL, I'm going to multiply the first terms. So I'm going to multiply 5x times 2x. So I'm going to write this one out in a lot of detail for the first one. So we have 5x times 2x for my first terms, plus my outer terms is going to be 5x times +1, so plus 5x times 1, plus my inner terms is going to be -3 times 2x. So make sure if you have any negative signs or subtraction signs in front, you want to take those with that. So this will be -3 times 2x, plus my last terms will be -3 times +1. Sorry, we ran over there a little bit. From here, we want to multiply those all out. We know from properties of exponents that if I have the same base, I add the exponents. So 5x times 2x will give me a 10x to the second power, plus 5x times 1 will just give us 5x. -3 times 2x will give us -6x, and then -3 times 1 will give us -3. Now that we've simplified each term, I want to combine any like terms that I have. In this case, the 5x and the -6x are like terms, so I'll end up with 10x squared minus x, since I had 5 of them minus 6 of them, minus 3. And that will be our final answer. So in this section, we're just practicing multiplying everything out using the FOIL method or the double distributive property. We're not actually solving for x or anything. Let's look at our second example. So in our second example, we have 3x minus 4 times x plus 2. So to multiply my first 2 terms, I would multiply the 3x times the x. I'm going to do it in different colors so that we can still see the prior answer. So 3x times x. When I multiply those two together, I'll end up with 3x squared, since I'm adding the exponents. Then on the next term, I'll get plus 3x times 2 will give us 6x. For my inner terms, I get -4 times x, which will give us -4x. Then on our last terms, we get negative 4 times 2, which will give us negative 8. So in the second example, I didn't take the time to write out the first step of the two terms multiplied next to each other. Instead, I just did that simplification in my head and wrote it down. If you would like to still write out this first step of having the 3x times the x first, feel free to do so. I'm going to jump right into the a little bit more simplified version. From here, we're not quite done yet. We actually have to make sure that we combine any like terms. The 6x and the negative 4x are like terms, so our final answer will be 3x squared plus 2x minus 8 then. Let's look at example 3. So in example 3, we have a minus 6 times 4a minus 7. Why don't you guys pause the video and then we'll check it together. Okay, let's check example 3. So my first terms is a times 4a, so I'd end up with 4a squared then. Then I get a times negative 7 to give me negative 7a. My inner terms is negative 6 times 4, which will give us negative 24a. Then on my last terms, I get a negative 6 times a negative 7, so I'll end up with a positive 42. We've now FOILed, or we've multiplied that out. So our next step is to combine any like terms if we can. And in this case, again, I can combine our middle terms here. So I end up with 4a to the second minus 31a plus 2 then. And that will be our simplified or our multiplied out form for example 3. Why don't you guys pause the video and try example 4 on your own first. Let's check example 4. So in example 4, I have 2x squared times 2x for my first terms. That will give us 4x to the third power because I'm going to add those exponents. So 2x's plus one more will give me x to the third. My outer terms when I multiply will be 2x squared times negative 5, which will give us negative 10 x to the second power. My inner terms, positive 3 times a 2x will give me a positive 6x. And then on my last terms, we get 3 times negative 5, which will give us negative 15. Now from here, we'd want to simplify and combine any like terms. But in this case, we have no like terms that we can combine, so this will actually be our final answer. I'm going to erase those lines so that we can box it. And this will be our final answer once we FOIL. Example 5 says x plus 8 times 3x minus 1. Why don't you guys pause the video and multiply out example 5 on your own first. Let's check example 5. So for our first terms, we have x times 3x, so that's going to give us 3x to the second power, plus our outer terms will be x times negative 1, which will give me negative 1x, so negative x. My inner terms is 8 times 3x, so I'll get plus 24x. And then for my last terms, we get 8 times negative 1, so I will get minus 8. Now that we've FOILed this out, you'll notice we have 4 terms again, like we've had in every problem. But from here, if I can simplify, I will want to do so. I do have some like terms that I can combine, and we end up with 3x squared plus 23x minus 8. Okay, example 6 says 3x squared, says 3x minus 7 times x squared plus 2. Why don't you guys pause the video and multiply that out on your own first. Okay, let's check example 6. My first terms is going to be 3x times x squared, which will give me a 3x to the third power. My outer terms is 3x times 2, so I'll get plus 6x. My inner term will be negative 7 times x squared, so we'll get negative 7x to the second. And on our last term, we'll get negative 7 times 2, which will give us negative 14. From here, we want to see if we can combine any like terms. And in this case, we don't have any like terms to combine, but I do want us to keep practicing stuff from our prior lessons. So let's rewrite this in standard form. So think about what you would have to do to rewrite this in standard form. Remember, standard form goes from the highest exponent down to the lowest. So 3x cubed does go first, but the negative 7x squared should come second, then the 6x, and then the constant term. So although the answer above was correct and we were technically done, if we wanted to do that additional step of writing it in standard form, we would need to just rearrange those terms. All right, let's look at some more examples. So example 7 says x plus 8, the entire thing squared. So this problem right here, we've got to be very careful about this. So think about what the definition of something squared means. So when I write x squared, what is that really representing? What x squared is representing is x times itself. So when I have a quantity now of x plus 8 squared, what this really means is x plus 8 times x plus 8. And we want to make sure that we're going to write it as two binomials times each other, so we make sure to multiply everything out. One of the most common errors that we see in a lot of math classes is that we decide to just distribute the square here and we say, oh, well, this will give us x squared plus 8 squared, which would be 64. This is not going to be correct, and we're going to see why when we go to actually FOIL and multiply out these two binomials. So if we start with our first terms, I'm going to get x times x, so I do get an x squared. Then my outer terms will give me an x times an 8, so I'll get plus 8x. My inner terms give me 8 times x, so I get another 8x. And then my last terms is 8 times 8, which will be 64. But the difference here is if we were to just distribute the square, which we don't want to do, we would be missing out on these middle terms here. So it's very important to write out when you have a binomial to the second power as itself times itself. That way we can make sure we're FOILing this all out. Because our final answer here is going to end up being x squared plus 16x, since I can combine some like terms, plus 64. So when you think about just squaring each term, the reason that doesn't work is because you are missing out on the middle information, which we get by multiplying the outer and the inner terms together. So this is what we call the freshman's dream in math. We wish it was as easy as just distributing that square, but it is not. So as a side note over here, I want to just remind us that if I have something squared, this does not equal each term individually squared. And we call that the freshman's dream in math because we wish it was true, but it is not going to be true because we're missing out on what our inner terms are producing here. So don't fall into that silly trap that's really easy to fall into. Just think about instead, how can I rewrite this x plus 8 squared? I could rewrite it as x plus 8 times x plus 8. Okay, let's look at example 8. So example 8 says 2a minus 3 to the second power. Again, we have this binomial to the second power, so we're going to want to rewrite this right away as 2a minus 3 times 2a minus 3. And that way this will help us remember to FOIL everything out. Why don't you guys pause the video and finish FOILing and simplifying this out, and then we'll check it together. Okay, when we go to simplify this, I get 2a times 2a, so I'll end up with a 4a to the second power. Then we get a 2a times a negative 3, which will give us a negative 6a. Our inner terms will be negative 3 times 2a, which will give us another negative 6a. And then our last terms will be a negative 3 times a negative 3, so I end up with a positive 9 then. I can combine some like terms, so my final answer will be 4a squared minus 12a plus 9 then. Let's look at example 9. So example 9 says 5x minus 2, the entire thing squared. Why don't you guys pause the video and simplify example 9 on your own first. Okay, let's check example 9. So remember, when I have something to the second power, the first thing I want to do is rewrite this as the 5x minus 2 times itself. That way I don't accidentally fall into this trap of the freshman's dream, which we know is not a true statement. Instead, I've got to start multiplying everything out. So 5x times 5x will give me 25x to the second power. 5x times negative 2 will give us a negative 10x. Negative 2 times 5x is going to be another negative 10x. And then negative 2 times itself will give me positive 4. The last thing I have to do is combine any like terms, so I end up with 25x to the second minus 20x plus 4. And that will be our final answer on example 9. Okay, let's look at example 10. So in example, we can see 10 through 12, we're back to a binomial times a binomial right away. So I can go ahead and start foiling. So I get my first terms, x times x will give us x squared. Then I get an x times a negative 9. So we'll have negative 9x. Then my inner terms will give me plus 9x. And then 9 times negative 9 will give me negative 81. If I can combine any like terms, I want to make sure that I do so. And the 9x and the negative 9x are like terms. And they actually cancel each other out. So I end up with x squared plus no more x's. So just x squared minus 81. Since the 9x and the negative 9x cancel each other out. Why don't you guys pause the video and try example 11 on your own first. Let's check example 11. We have 3x minus 4 times 3x plus 4. So this looks really kind of similar to what example 10 did, where I had one term that they're identical terms, the only difference is the plus sign or the negative sign. So let's see what happens here. So we get 3x times itself, so I get 9x squared. Then 3x times 4 gives me a plus 12x. Negative 4 times 3x gives us a negative 12x. Something's going to happen there with those two terms then. And then a negative 4 times a positive 4 will give us a negative 16. Again, we have two terms that are going to just completely cancel each other out, and I'm only left with a 9x squared minus a 16. So our linear terms, or just our x terms, ended up canceling out. Why don't you guys pause the video and do example 12 on your own first, and then we'll check it together. Okay, you might really be starting to notice a pattern here with these. Again, I have two binomials that look really close to each other. The difference is the x minus 2 versus the x plus 2. So probably something's going to cancel out again, but let's check it. So when I multiply these, x times x gives us x squared. Then x times positive 2 gives us plus 2x. Negative 2 times x gives us negative 2x. And then negative 2 times 2 will give us a negative 4. Again, our middle terms ended up canceling out, so plus 2x and negative 2x gives us just 0 x's, so I end up with x squared minus 4. So on this second page of examples here, we can tell that examples 7 through 9 are all very similar because there's a binomial to the second power, and then in examples 10 through 12, those were almost identical, but one was positive and one was negative. These are actually two special cases that we have here. So on our left-hand side here with examples, so these were examples 7 through 9, we had what we call perfect square trinomials, where I have one whole quantity to the second power with either a plus or a negative sign. That is always going to FOIL out to be something of the form where I have the first number squared plus 2 times a times b plus the second piece of that squared. And examples 10 through 12 were actually what we call a difference of squares, where I have the identical things here. So I have a, and then I have b and b. The only difference is one has a plus and one has a negative. When that happens, the middle terms here will always cancel each other out, and we're just getting left with the a squared minus the b squared. So those are just some special vocab words that we do have there in this video. So in this video, we practice how can I multiply a binomial times a binomial and work through what it means for the FOIL method of multiplying the first terms, the outer terms, the inner, and the last terms. And we can extend this concept to multiplying binomials times a trinomial or a trinomial times a trinomial by thinking about it as distributing each term to every single term in the opposite polynomial.